Hmm. Are you able to see my screen, right? Uh,
Yes.
hmm. Till that, I think we have covered. Let me show you the course structure as well, so that we have just covered the what is the data warehouse. Data mart also just a sub part of your data warehouse. And the OLAP, OLTP, I will explain some details. Just we'll take some example. Uh, just differentiate with both example. Let me explain first this one so that we can clear one by one. Data mart, you understand, right?
If you can explain again.
Data warehouse, just a sub part of data mart. Suppose your industry is small size, like you just take example like medical store, right? So as a example, any just I'm taking an India example. One is Apollo. There is a small price opening the outlet to multiple cities, small and small, right? He did not require like a big data warehouse. He wants to like mostly 1,000 or 20,000 items, list of items. He wants given the requirement, share the requirement like we need only just a small data warehouse so that I can put my item list there. And if required, if someone is going in my shop, come in my shop and wants some medicine, then we just scan that screen and only for inventory management kind of, right? So that there we create like data mart so that we can provide the small database. Data warehouse we are using say big industry like enterprise industry. There is multiple manufacturing products and all that there is working, or like Amazon kind of, or Flipkart kind of online shop. There are the multiple cities belonging. There is a huge data. That's why we create the data warehouse comes, right? You got it right, data mart.
Right, yeah.
Hmm. Now coming OLAP, I'm just showing you what OLAP. I think I already explained OLAP and OLTP. OLAP actually we are using for analytical processing data. Means we are OLAP concept we are using in data warehouse data mart. So that for the we store the data as a historical format. So that on the so that we can analyze, we can do the analysis on the basis of that data. And the OLTP actually concept we are using as a ERP kind of, we are online transactional processing on daily basis. Whatever data is comes by customer or anything, right? We are doing that data we are storing on daily basis. But that data after that, once daily task is completed, we all data we combined and store in our OLEP data warehouse. And data warehouse will maintain the data day by day. That is called the OLEP. So if you maintain the data as a historical format, like 1 month, 2 month, or whatever you date your time, means you already read that concepts, subject oriented, volatile kind of that. On the basis of that, according to your requirement, you need to prepare your reports to present to business based on that. That customer based on the city, based on the time, in particular this month how many sales done in last, right? That kind of analysis you can do with the help of OLP. OLTP always concept comes in ERP, like daily data transactional processing. The okay, just I'm explaining in detail. Come in page. One second. Hmm. OLAP actually just put it some differentiate. Actually, OLAP involves historical process. Already I informed we are using for historical format, just a sequence way. And OLTP actually involves day-to-day processing, right? And the second difference is OLAP systems are used by knowledge workers such as executive manager and analytics, because that person is taking the decision in business in any industry. That's why he said at executive level, manager level, and analyst level use the OLAP data. We are not providing all data access to other people, like who is the data entry persons, kind of, right? We are providing the data who is the manager level and executive level. They can take a decision on business, right? And OLTP actually system are used by clerk, DBA, or database professional that are basically used. Clerk, why is saying clerk means that kind of data entry person who is suppose any person comes in your a company, or purchasing something in the Amazon website, you are purchasing, your information will store, like your product item, which item you purchase, and what is the price, or this kind of information is stored in database on daily basis. So that's why it's calling the OLTP, OLTP, so that on the basis of that daily data we are storing one by one. But OLTP, we just combined all data, either daily basis or weekly basis, we transfer in data warehouse. Got it?
Yeah.
Third difference is it is used to analyze the business. Because we analyze the business, then we can provide some truthful information to company, so that company take a decision. So always this OLTP using for decision making, kind of. And OLTP is used to run the business. Run the business means a daily basis, any shop, anywhere, like grocery market, kind of. There you go there and some purchase some input products, and pay some money to an counter, right there. So that are the daily one by one data is storing. That are called the OLTP concept. Fourth difference, actually, it's focuses on information out, actually. And OLTP actually focus in data only. Data only, why? Because you're collecting the data from one by one. uh, uh, OLAP is actually facing the information out. Suppose we, based on the data, he's analyzed that things, how many sales done by today, how many sales done by weekly basis. So he take the information out. Information out means so that a business or mayor take the decision on the basis, okay, this product is selling by weekly on huge. Suppose any festival there, so maybe that product is still more. So according to that information, he prepare before that. That's why he take the help. Because why? How to help this OLAP to our business? That help us so that you can pre-plan accordingly, right? Fifth difference is actually it is based on star schema, snowflake schema, and fact constellation. This one will explain after this. What is the star schema, snowflake schema, and fact. So just I'm explaining here some minor. Star actually, star kind of star means in between, in middle where your fact is there, and surrounding is dimension. Your fact will coordinate with all dimension whatever you created. Suppose just I'm taking example in medical store. The one fact you have created for storing the all item, all transaction data, rate, and everything. And you have created multiple dimension. The multiple dimension means kind of your product master, your rate master, right? Is some your medicine store in one table, some rates store in another table, some discount table, right? So that table will coordinate your fact transaction table, right? That are called the star schema. Means all star schema, the primary key will be coordinated your fact table. That's why you calling one all key column will be there in your fact table, right? That's why we calling the star schema. And where is a snowflake? Snowflake actually one to one. Suppose just I'm taking a previous example, is fact is coordinated to all dimension, but here fact is not coordinated to all dimension. Fact coordinating first your rate dimension, then rate will coordinate your another sorry, fact will coordinate with item master, item master will coordinate with rate master. Dimension to dimension coordinate. That's why we call the snowflake. Got it? So these are the difference in star and snowflake. Star always coordinate with all fact will coordinate all dimension, whereas snowflake will coordinate with dimension to dimension. Then fact will coordinate. Fact always not coordinate into all dimension. That one is actually differentiate. Let me explain that one also. What is so that we can conclude. Hmm. Here actually, star schema, some details. A star schema is a relational database. Yeah, always relational because we are using in our data warehouse for representing multi-dimensional data. It is simplest form of data warehouse schema that contains one or more. One either you can take one. Why you are saying contains one or more means one maybe according to your industry. Either you create a one dimension or two dimension or just a requirement or more dimension and a fact tables. It is called a star schema because the entity relationship diagram between dimension and fact table resemble a star where one fact table is connected to multiple dimensions. Got it? The center of the star consists of a large fact table and its
Oh,
point toward the dimension table. Got it?
yeah. I have one question. Like,
Huh.
what are we referring to dimension here? Like, what is
Dimension
dimension?
means, yeah, let me show you one example. Suppose, uh, wait, hmm. Suppose this one is fact, right? Uh, if fact table, just take example, this is the fact table and fact table is employee table, right? Wait. Dimension means here is one dimension, here is another dimension. Okay. Dimension means where is fact. Fact is actually just take example is employee table, right? Not a employee table. Employee table is OLTP type of table. I'm just creating employee EMP. Uh, how to create EMP underscore TGT underscore EF, right? These are the your fact table, and here is dimension table. Dimension table you created just like your in your employee table having the employee table, department table, right? Sales table, salary table. So this one on the basis of that your department table you created the department dim table dimension. Got it? On the same you created the salary dimension. Okay. I'm just explaining this one is data warehouse concept. Same table, if you notice, if you go login in Oracle, the Oracle having the employee table, right? Employee department and salary table and all, right?
Yeah.
That table, that information you want to pull in your data warehouse. The how you pull, you just create the dimension and fact table, then you can join. We need that data, department-wise data, and we are not going to store that data in completely in fact table. That's why the dimension and the fact is comes in picture. Dimension means small data. Dimension means master data. Master data means your less data. There is no any transactional data. There is only item master. There is not changing daily. Suppose in any industry we go there and just create the item master in once. Once we are increasing the item, then we'll increase. And another one is price master. Price we are not changing daily, right? We have stored the price where weekly basis or monthly basis or quarterly basis kind of we change the price. So that's why we comes a dimension comes in picture. Fact means we are storing transactional data always. So here it comes in picture. Why is showing the star? Star means this middleware in fact, right? And in surrounding you can coordinate with the dimension. Suppose here department dimension. We want to store the data in our target table in our data warehouse. Um, uh, employee with what is the department, what is the salary, all information is stored in our employee TGT fact table. So we coordinate with this table, department dimension, salary dimensions, and other one is like location dimension. Okay. City dimension. These are the 4-dimension table. We need that one fact table there each store the information with employee name, employee details, department number, salary information, location, and the city, right? So we need there are the 4-dimension table in our data warehouse and one fact table. So total 5 table will create, and we create the how many mapping. We first store the data in our 4-dimension, then in last we'll store data in fact table. So there are 5 mapping will create. 4 mapping will create only load the data from dimension to OLTP to dimension tables, right? So department data will store in department dimension, salary information will store the salary dimension table, right? Location table, location data will store location dimension, city data will store city dimension. After that, we'll prepare one more transactional mapping. They are having the complete logic there. We'll write the query from source and store the data here in fact table. How when department dimension and salary dimension comes in picture, when I'm going to prepare a report dashboard, then your all dimension will come in picture. We are not going to your OLTP server. We for analysis purpose we use the only data warehouse. Then you need the department name, some other information, then we'll join that table, fact table to dimensions table, so that we can extract some other informations from that table. Because in fact table we are storing only key column, not storing your department number, name, and other information in fact table. We just storing the key column. Otherwise your column will increase, and when you need that information in your report, you need to join the board table based on your reports requirement. Got it?
Yeah.
Yeah, thanks. Coming picture, star. So that are the star actually. Basically, in the industry, mostly we are using the star because star is working best approach to have. But yeah, snowflake also, because somewhere using the snowflake. But yeah, star is always better. Star mostly industry, most process we are using the star, because there is actually most industry using. There is some easy and understanding perspective also, that one is easy. So mostly in design especially using the star. Now how what is the step designing star schema? Like first step is actually identify a business process of analysis like sales, finance, and other things. Then identify measures of facts. Measures means what is the currency. Measures means what is the formula I created. Suppose we need the total sales. You need the total quantity kind of this one is called the measures in your data warehouse concept. If any total amount you want, so that one will call as a measures. Third type, what you, this one is how to design, this one is process. If you go industry, that one is scratch level. You need that information before, just a prerequisite kind of. Third one, identify dimension for facts, like what is that, how many dimension will create. So he just said for a product dimension, location dimension, time dimension, and organization. This one time dimension is always means most of the fact will required. Why I'm saying the time dimension? Time dimension means you need the data weekly, monthly, quarterly, right? That the time dimension will create by default, so that we can join that time, means join with system date, or you create the quarterly, monthly kind of. Then you can take the data, means show the data in dashboard with time wise. So that one is most important in your data warehouse, time dimension. And that one, last one is the list column that describe each dimension, region name, branch name, kind of is just take an example. And the list out means prepare the list. How many columns will create in dimension? That one just take a employee table. The employee table having the employee name, number, department name required kind of. This information will just prerequisite. You just prepare and then you go for designing something. And he now last he determine the lowest level of some fact table. Lowest level means just to find out the lowest granularity, so that we can suppose you are going to design the any dashboard for reporting perspective, or you just providing data to our your report perspective. In your fact table will design the last granular level, so that you can see, you can join the data to that level, right? To show the data. Suppose granular means, suppose we want to data, just I'm taking example here, time dimension. One data, first dashboard will show the data your quarterly wise, my 3 month data, right? 90 days. We show the data in 90 days. Then I need the data location wise, right? Then you click on the location, then data will show the location wise summary. Then I need the information product wise, then I click on product column. Then data will filter out as a product basis. Okay, this data will summarize this product is sold in particular in 90 days, how many and how much revenue comes in our industry, or how many product will sell sold out, right? That information is called like a granularity level. Why we are creating the dimension we create for the granularity, so that you can show the data at that level, right? Kind of filter you can understand, we are using as a filter, so that you can show the data at that level. Someone wants to see the data at department wise, then you can show the data at department. Someone wants to see only a high level like 90 days, how many sales done, so we show that, right? So these are the actually basic prerequisite when I'm going to design the star schema, right? And some important aspect of star and snowflake, that one you can just read. I'm just high level, that one is describing. In star schema, every dimension have the primary key. That one the prerequisite concept kind of having will have a primary key always required, so that you can join that primary key to your fact table as a foreign key. And in a star schema, a dimension table will not have any parent table. Dimension, here why is saying that there is no any parent table. Always I was show you here a design will be there. This one is your dimension table. There is no any parent table here, right? Only your child table here, fact table. Always dimension will come in. If you are creating a star schema, the dimension will always coordinate with fact table. There is no any other table to coordinate with as a parent, right? So this one is, if any star is there, so you can understand like this. If your parent, your dimensional coordinate to any parent table, then that will call as a snowflake schema, not a star schema. Got it? Now, where is a snowflake schema? A dimension table will have a one or more parent table. Is called the snowflake schema, because in snowflake design, dimension will coordinate with your parent table, one or more. And hierarchies of the for the dimension are stored in the dimensional table itself in star schema. And whereas hierarchy are broken into separate tables in snowflake schema, these hierarchy helps to drill down the data. You understood the drill down means, right? If you go anywhere, if you see the dashboard, drill down means we just filter out, filtering, go in lower granularity. Suppose first your dashboard showing bar chart is 90 days data, then we click again on that, so data will filter out in next level. Next level means suppose here I'm just taking a time and Purge data will show in 90 days. Then again we click on that one, the drill down on location level. Then drill down to product dimension. Till that, because you have created only these dimensions, so your data will filter out to that level only. So that one is called a drill down for data from topmost hierarchy to the lowermost hierarchy. Kind of. So this one is basically using by the reporting perspective. But yeah, as a ETL, we just design this fact star fact and the dimension on the basis of requirement, because we know that some reporting, because on the basis of that we design our data warehouse. We are basically our responsibility is our ETL. We just load data from OLTP server to OLAP. That's it. But yeah, we knew the concept of that requirement, so that we can design our data tables accordingly. Otherwise, when reporting team will come, then he said that table is required kind of. But yeah, the ETL team will coordinate with reporting team and just understand the requirement. Then on the basis of that requirement, he go and create the table in your data warehouse, OLAP server. These are the hierarchy. Hierarchy means hierarchy is nothing. Hierarchy is actually you understand parent-child relationship kind of. Yeah, in any organization in go there, there is some hierarchy. Some topmost is a manager, then senior manager kind of, and upper manager means executive. So there are some structure. Here is hierarchy. There is a logical structure. Ritika, you understand? Na? Go ahead. If any question.
Yeah, I'll ask if any question. Yeah.
Hierarchy means, just explaining, hierarchy means a logical structure that uses ordered level as means of organizing data. Like a hierarchy can be used to define data aggregation. Aggregation means like we summarize the data. For example, time dimension. A hierarchy might be used to aggregate data from the month level to the quarter level. 40 minutes, one slot. Yeah, will again. Yeah, sorry. Yeah, so yeah, quarter level from the quarter level to the year levels. Like that, the basis of your requirement, we can design your report accordingly. That one is called hierarchy. Means saying the if you comes in hierarchy in the time dimension, the time in time dimension there is month, quarter, half year, and year level. That hierarchy will create. You can create in your data warehouse. And the hierarchy can also be used to define a navigational drill path, regardless of whether the label in the hierarchy represent aggregated total or not. Kind of total or means aggregate that amounts or your product or kind of you how many product is sold out, how much revenue generated particular in that quarter, so that on the basis of that we can analyze how much means budget we have budgeted the amount, means budget we have planned that amount forecasted amount, and but we receive the amount in that level, so that analysis on the quarter level, so that we take the decision on next quarter. Now comes what is the fact actually in our data warehouse. Fact actually in a fact is nothing. There is the actually star schema that contains fact and connected to dimension. I was already show the some figures, a diagram. How what is the structure of that? A fact table is typically has two types of columns, like those that contain fact and those that are foreign key, two dimension table, right? The primary key of a fact table is usually a composite key that is made up for all its foreign key. This one is new. Actually, all fact table is saying fact table is star schema that contains fact and connected to dimensions. Understood? After that, fact table typically has two types of columns. One is one is the foreign key two dimension table. Another one primary key of fact table is usually composite key. Must there is two column always. If you created the fact table having the own primary key, that one called as a composite key, right? Another key having that one is the dimensions foreign key, because why you are creating the foreign key in fact table for that dimension. If you both join that table for dimension table, then you need to have the column so that you can join. So that one is called as a foreign key in your fact table. That foreign key column is your dimension primary key. See here, just one example here given. There is sales fact table, right? And left side is product dimension tables, and now down is location dimension table. Here is right side is organization dimension table, and there is time dimension table. Your product dimension table having how many column? There are the total 6 column. Product dimension identifier. There was this one is the primary key. Product category name, product subcategory name, product name, product feature description, date, time stamp, right? Then location dimension having the own primary key. That table have the own primary key. Country name, say state name, country name, city name, date, time stamp. Same right side is dimension table, organization dimension table having the primary key, corporate office like that. Time dimension having the your time dimension identifier as a primary key. Year number, date of year, quarter, month, so right. These are the your time dimension. Your sales fact, how it's designed means total is 4 dimension, right? So 4 foreign key will create here in your sales fact. Got it? Here time dimension, if you notice here, time dimension, this is the
Right.
foreign key. Here is your time dimension primary key. In your sales fact will primary foreign key. Because why we are creating foreign key here? Uh, when you're going to extract the data from sales quarterly, monthly, then we need to join from that table. That's why we need the foreign key required in sales fact table. Same as similar as location dimensions, a foreign key, product dimension, foreign key, and dimension. Total 4 means basis on your dimensions table. You can create the foreign key in your fact table accordingly. That one. Then your other column is sales dollar, means how many sales done in dollar. Actually, the currency is showing in dollar. And another date time stamp. Date time stamp like we pull, because date time stamp everywhere is same column to be pulled from any tables, right? These are the actually star schema structure in some real world. Suppose we go any industry, the basis of that industry, we can create the fact table like the industry belongs to your corporate level, then you can create the fact table accordingly. Basis of the in name, because we are sales is some common word. That's why most of the industry using the this kind of what, because mostly using the sales purchase kind of. So he has created that one. The basis of industry, you can create the table name. There is no any restriction there. Yeah, but yeah, design will be like this.
Okay.
Ritika, any question here?
No.
Yeah, okay. I'm going to next. Here is just explain. You can just read out. I think already shared the document. You can read, right? So there is some explaining what is the sales order value for particular product kind of. You can create accordingly. Okay. Now we'll explain the what is the snowflake actually. Snowflake already explained. That one is having the parents of that snowflake. A snowflake actually is terms of the describe star a structure like normalize through the use of outrigger table. Like example, a dimension table hierarchy are broken into simpler table. So just see here in a structure. Suppose if you see notice in your star schema, there is a sales fact directly connected to the product dimension, right? But here product dimension having the one parent is product category lookup. That one, what is he actually product category code, product category name, and date time stamp. Means in a snowflake structure, your dimension having the parents means your dimension can coordinate with other dimension table. That one structure called as a snowflake scheme. These are the difference actually. More there is just time in star schema. example, we had 4 dimension like location, product, time, organization, and the fact table cells. In Snowflake schema, the example diagram show like below. There is the 4 lookup table we have created. The region is that hierarchy, category, branch, stage, and a month. Like, so the every dimension is coordinating with its own parents, right? Your organization is coordinating with branch lookup. You are, because some branch name and time stamp. Why is creating the branch? Because your organization having the multiple branch in your city, location wise. That's why I created the branch. So you need the snowflake kind of concept in your industry, because your organization, their organization having the all details, region, code, branch code, right? Yes. Your structure also will be changed in dimension. Your dimension will keep as a foreign key, as a branch code, because that organization is coordinating with branch table. You need the foreign key in your dimension table as well. Got it? As similar, your time dimension also, your location dimension also will take, right? So these are your star schema and snowflake. This one is the basic things. Always using all most of the industry using this concept star and snowflake, either using star, either using snowflake. Got it? Now we'll explain some what is actually more in fact. Fact is also some types, right? Ritika, actually it will disconnected within 5 seconds. So
Okay.
we'll reconnect again.
Okay.
Hmm. I'm just disconnecting. I think it will automatic connect. Less than yeah, just going on fact table. Fact table actually what already explained that a centralized table in